One stop. One stop. One stop science shop. Hello, I'm Mercy and welcome to the One Stop Science Shop, the place for curious minds with science-related questions. We have a question already. Juhi writes in from Hong Kong. She has a question. What do atmospheric particles do in the sky? That's a good question. Let's try and find an answer. Have a look at what I got here. I'm gonna create two different weather conditions in the same jar using some curd, some milk, water, and a torchlight. Let's pour some water into the jar. Then goes in the milk and the curd. We have to stir this properly to get an even mix of yogurt particles, milk, and water. And before I get on with the next step, I have to turn the lights off. Now I'm gonna grab my torch and shine it on my milky solution. There you go, your blue-tinged morning skies. And as I move my torch down, the golden hues of sunset. Let me explain the science here. Now, the tiny particles in the milk act just like the tiny particles in the atmosphere. They scatter the light shining upon them. When the light comes from the side of the jar, the light of shorter wavelength, like blue light, is scattered the most. So that's the color we observe. And when we shine the torch from the back of the jar, the light is scattered differently. This time, most of the blue light has been scattered away from our line of sight. So, the dominant color to reach our eye is red. Hence, the solution in the jar now appears reddish. So the next time you look up at the blue sunrise or a red sunset, you know exactly what those atmospheric particles are up to. To create your own sky in the jar, have a look at what you need. A glass jar, some milk, curd, water, torchlight. Wasn't that a fun experiment? I hope you give it a go at home with your friends sometime. We have a visitor. Let's find out who it is. Hey, come on in. Welcome to the One Stop Science Shop. My name is Mercy. What's your name?
I'm Vanya.
What class are you in?
I'm in 4th.
What are your favorite subjects at school?
I like math and English.
Alright, why math?
Sometimes I like solving the sums.
What about your other interests?
I like playing with my dog. I like singing and like playing the piano.
So Vanya, what brings you here today?
The other day I was out cycling with my friends and we got into an argument about why the sky is blue. Is it just the reflection of the sea? So I came here to find the answer.
That's a great question. But there's a great story behind the person who gave the answer. Let's have a look.
Okay.
This is Chandrasekhar Venkata Raman, better known as C.V. Raman. Thank you. Now, he won the Nobel Prize for Physics in 1930. In fact, he was the first Asian and the first non-white to receive a Nobel Prize in the sciences. C.V. Raman was born in 1888 in Tamil Nadu in the small town called Thiruvannaikaval. These are his parents. He had many siblings and was one of 8 children. Raman was a government servant, but he loved science, so in his spare time, he started working at the Indian Association for the Cultivation of Science in Kolkata. Here, he studied the acoustics of musical instruments, particularly Indian drums such as the tabla and the mridangam. His first trip outside India was to Oxford in 1921. On his way there, he was intrigued by the blue of the sea. Many believed that it was a reflection of the sky, but Raman knew that there must be more to it than that. The search for the answer led him to carry out many experiments in Calcutta, but he needed more instruments. So he wrote to industrialist G.D. Birla asking him to fund a spectrograph. Raman promised that he would use this to win a Nobel Prize for India. He kept his promise. In 1930, he won the Nobel Prize for the Raman effect, which explains the scattering of light. Raman observed that when a beam of light is deflected by molecules, a small fraction of the light scatters. Now, most of the scattered light is of an unchanged wavelength, but a small part, however, has wavelengths that change or are different. Raman announced this discovery on 28 February 1928. This day is celebrated as National Science Day in India. In the history of the Nobel Prize, nobody was awarded one so quickly after their major contribution. On average, it takes about a decade to recognize the merit of any discovery. But in Raman's case, it took just 2 years. They say that Raman cried during the Nobel Prize ceremony because there was a British flag rather than an Indian one on his chair.
So what exactly is the use of the Raman effect?
Every molecule has a different Raman pattern. It's a bit like our fingerprints, which are unique to us. Raman spectroscopy is used to analyze a wide range of materials, including gases, liquids, and solids. Highly complex materials such as biological organisms and human tissue can also be analyzed. Today, Raman scanners are used in airports to detect drugs and other illegal substances.
I have an interesting fact about him. The original spectroscope he used cost him 300 rupees. I bet the ones they use in the airports today must be costing millions of rupees.
Wow, I didn't know that. Thank you for telling me. A spectroscope is a device that shows us how different light sources make different spectra.
What kind of lights?
Anything from sunlight to candlelight, fluorescent light, LED light, tungsten light.
How can we see it?
Let me show you through an experiment. I have everything I need in my one-stop science box. You can take the things out of here while I get rid of this.
We have glue, tape, black tape, a cutter, scissors, a pen, a scale, a CD, a laser light, 2 torches, an empty toilet roll,
And 2 business cards.
and 2 business cards.
First of all, we're gonna glue the CD to the inside of the box.
Which side?
We'll have the shiny side facing the box or facing outwards towards us. I'm cutting 2 strips of tape. Glue it to the sides up and down. We're gonna glue the CD right to the end of one side. Vanya's gonna put more tape. On the side opposite the CD, we're gonna draw out a small square and we're gonna cut it up. If you're doing this at home, you might need an adult to supervise this. So we're gonna glue the 2 visiting cards on top of the hole that we just made, keeping a tiny gap between the 2. I think we need to tape this part a bit. This slit is for the light to shine through. We're going to measure out 2 holes here. Do you want to make a circle around this? Can you reach? Vanya has helped me mark out 2 circles overlapping each other, and we're gonna cut along the outer lines. Now we're gonna tape the box, so we'll let no light enter the box. Now we have to fix our eyepiece. I'll use this tape first, and then we'll tape it up with dark tape. So what you can do is use chart paper or other colored paper to cover it very nicely. Let me show you one I already made yesterday. Well, I used some white paper and then added a blue strip, and there's some color on the eyepiece. Are you ready to see the sides?
Yeah.
Okay. So we have 3 different kinds of lights, and as I shine them through the light slit, you look through the eyepiece and tell me what's going on. Here you go, that's the laser beam.
It's showing so many different colors.
Great. Now I'm gonna put a different light. Now let's see what happens with a white light.
Looks like a rainbow.
Is there a difference in the different lights that I'm putting through?
Yeah, wow. There's a spectrum of colors.
This is the yellow light of a flashlight.
That's different. It's got blue in the end. What's happening inside the box?
A spectroscope breaks the light sources into different components, so when the light source changes, so does the components. To make your own spectroscope at home, have a look at what you need.
Old cardboard box, glue, tape, black tape, cutter, stationery, a CD, different light sources, empty toilet roll, 2 business cards.
Thanks for building this with me.
It's my pleasure. Thank you for coming by, Vanya.
Of course.
I hope you had fun.
Yeah.
Thank you for joining us. That's all we have for you today. See you next time as we try to answer all your science-related questions at the One Stop Science Shop.